Good morning, everyone. I'm Jenisha Shrestha, and I'll be briefing you on behalf of our workshop team regarding a water reuse strategy for New York City. I'd like to thank our faculty advisor, Dr. Nancy Degnan, and our workshop managers, Caitlin and Bahi, for all of their support and guidance throughout this unique semester. As for our agenda today, first, I'd like to talk about the context of our project and introduce our client. Next, I'll go over our objective and the methods we use to conduct our research, and then present our key findings and recommendations for our client. But before I proceed, let me give you our working definition of water reuse. Water reuse is also known as water recycling or water reclamation, where wastewater and rainwater is intentionally captured and treated through multiple purification processes and then repurposed for potable use, as in drinking, or non-potable use, as in toilet water, laundry, or irrigation. New York City is considered to be water rich, meaning it has abundant water resources with the infrastructure to deliver clean, high quality water, as well as effectively handle wastewater. As you see on this map, the city has an extensive drinking water supply system to deliver almost 1 billion gallons of water to 9 million residents on a daily basis. It comprises of about 2,000 square miles of watershed north of the city and about 7,000 miles of water mains, tunnels, and aqueducts. The city's wastewater management system is just as extensive. There are 7,400 miles of sewer lines, 96 pump stations, and a system of 14 treatment plants that collectively treat about 1.3 billion gallons of wastewater each day, which is ultimately discharged to New York harbors. So why should New York City, as a water-rich city, think about water reuse? First is our aging infrastructure and the need for its repair and maintenance. The Delaware Aqueduct, which supplies nearly half of the city's water, is currently leaking about 20 million gallons a day, and its planned repair in 2022 has already prompted the city to enact a water demand reduction plan. Second is the issue of combined sewer overflows, where intense rain events cause storm water mixed with untreated sewage to be directly discharged to our waterways because our treatment plants are unable to handle the increased flow. So on-site water reuse systems can help reduce the burden on our wastewater treatment plants and prevent these overflow events and subsequent waterway pollution. Moreover, it can also help reduce emissions from our treatment plants, which is currently the second largest producer of methane in New York City. Third is water reuse's role in advancing climate change resilience. In 2012, Hurricane Sandy's storm surge flooded the city's pumping stations and wastewater treatment plants, rendering them non-operational for 4 days and spewing nearly 2 billion gallons of raw sewage into the waterways. In contrast, the Solaire, a Battery Park City building complex with an on-site water reuse system, continued to provide uninterrupted wastewater treatment. By implementing a citywide water reuse strategy, the city can increase its resilience and protect people, commerce, and the environment. For these reasons, our client, Mr. Alan Cohen, the Managing Director of Integrated Water Management at the New York City Department of Environmental Protection, wants to be proactive and design a water reuse strategy for the city. This semester, Mr. Cohen asked our team to summarize the questions, challenges, and opportunities for water reuse in New York City, and to make recommendations that highlight programmatic realities of setting up a water reuse strategy by documenting lessons learned from the experiences of other municipalities in the country. In discussions with our client, he suggested a research framework that was both very helpful to DEP and also helped guide our inquiry process. It included looking into the technology, public health, finance, and governance considerations. This framework was the foundation to our research method. As for our research methods, we reviewed seminal literature on water reuse policy and practices within the US and internationally, as well as we conducted phone interviews with 13 experts to probe for insights, guidance, and advice regarding the 4 components of our framework, which ultimately helped us develop a set of distinct recommendations for New York City. The experts we interviewed included public sector policymakers and practitioners from 3 renowned water reuse cases in the US. These include the city of San Francisco and Orange County in California and the city of Austin in Texas. We also talked with representatives from the private sector, engineers, scientists, and decision makers throughout the country. Now, let's move on to our key recommendations presented through each component of our framework. Due to the lack of space and aging infrastructure, it is quite challenging to develop a centralized water reuse plant in New York City. Therefore, we recommend that the DEP frame their approach to promote decentralized systems. Using a combination of individual building and district-scale water reuse systems will help address the unique density issues in the city. For instance, homeowners on Staten Island will have a different reuse system than large capacity buildings like the Solaire in Battery Park. As one of our experts, Jenisha from Matrix New World Engineering and a fellow MPA alum suggested, the city should allow the markets to determine the type of technology to use rather than having a public sector mandate to use one technology over another. Public health has been the primary concern for water reuse systems at any scale due to the human health risk from opportunistic microbial pathogens and chemical contaminants. The current coronavirus outbreak has only heightened these concerns. While technology already exists to treat reclaimed water to levels that meet or exceed health standards, only having adequate technology and capacity is not sufficient. So we recommend the DEP to work closely with the Public Health and Buildings Department, as well as the private developers, to set up frequent monitoring, testing, and oversight of all water reuse systems. They should revamp and upgrade training to ensure that operators monitor for all pathogens, use appropriate purification technologies, and consistently report their findings to ensure public safety. The good news here is that in all of our case studies in Austin, San Francisco, and Orange County, they have reported 0 health issues so far associated with their water reuse systems. In terms of finance, the cost for decentralized systems depend upon their capacity, scale, and space constraints, and fall primarily on the building owners. Cost effectiveness is based on the return on investments. According to Ed Clerico of Natural Systems Utilities, cost estimates for these systems range between $18 to $50 per gallon, with smaller systems being more expensive. A system like the one at Solaire with a capacity of 25,000 gallons per day has a 10-year return on investment, whereas larger district-scale systems can provide a return on investment in less than 5 years. Given these differences in cost, we recommend that the DEP conduct more research to create and share financial guidelines that detail these figures for developers so that to help with transparent financial planning. If possible, the city should expand its existing grant program and offer incentives to encourage developers as well as homeowners to install these systems. In each of our case studies, the public sector managers emphasized that governance was a critical piece of water reuse effectiveness. We recommend that the DEP approach the establishment of standards, practices, and ordinances through an early and iterative collaborative process with city agencies, including the Department of Buildings, Health, Sanitation, Economic Development, and Mayor's Office, just to name a few, as well as engaging external stakeholders, including the public and the private sector. Finally, as Taylor Chang of San Francisco Public Utilities noted, it is critical to identify a lead agency to direct and implement the water reuse strategy. Water has been central to the development of New York City. Without the pristine reservoirs upstate and the extensive infrastructure, the city could not have grown to the size that it is today. A water reuse strategy offers New Yorkers the opportunity to optimize the city's existing system, promote water conservation, and prepare for climate change. When done right, it can be safe, innovative, and supportive of the city's path towards resiliency in this 21st century. Finally, we look forward to sharing our final report and findings with our client virtually on May 8th. Thank you all for listening, and I'm happy to take any questions that you may have.
Thank you. Okay, do we have any questions? Any questions from Okay, I see Anastasia has a question.
All right, you should be unmuted, Anastasia.
Yep. Good job, Jenisha. Well done. My question for you was, you said you researched some examples from around the world. Can you give an example of countries that are doing well, and is it possible for New York to adopt some of these wastewater treatment systems?
So we looked at some international cities like Singapore and whatnot, but a lot of the cases that we looked at came out of the necessity to have a water reuse system because we're water scarce areas. And New York is a unique case because it's a water rich city. But at the same time, it is feasible that New York can have a water reuse system. But as I mentioned, on a more of a decentralized scale where buildings or a group of buildings share one system for reuse rather than having a big treatment plant like the one in Orange County. They have a massive treatment plant that kind of serves the entire city. So I think for New York, the technology is specific to the buildings versus like a citywide scale.